Alright, so in this video we're going to do our first example of doing a confidence interval. And this is going to go back to the opening example of the module. So from our opening example, we had a random sample of 600 Boone County elementary school students. So that was our N. And we found that 29% of them were eligible for free or reduced lunch, which meant that we had a sample proportion of 29%. We're going to go through and do a 90% confidence interval for P, going through the steps that we learned in the last video. So my first step is to define my parameter in words. So P is going to be our population proportion of Boone County elementary students who are eligible for free or reduced lunch. This will always be in words. There's not going to be any numbers inside of it. Alright, so that's what step 1 looks like. Step 2, we're going to state our formula and then do our conditions that we have here for a categorical variable. So the formula that we're going to use is going to be this P hat minus this Z times that standard error that we talked about, with the same thing on the other side with that plus sign between it instead. So this is on your formula sheet, nothing you need to have memorized. Now for my conditions, let's look at our sampling method. All right, I don't know anything bad about how they chose those 600 students, so that seems okay. My N times my P hat, I already have both of those labeled, so we're good to plug those numbers in. So we get 174 for the N times P hat. And then for our N times 1 minus P hat, we get 426. Which is also at least 10. So our conditions are met. Next, we're going to be doing the actual interval. So looking at our formula up here, and so I'm going to erase those things I have labeled on it so we can see it a little bit better. So I already have my P hat as 0.29. I already have my N as 600. The only thing I need still is my Z. And that's finally where we're going to use this 90% confidence they gave us, which if I have 90% confidence, we're going to use a Z of 1.645. So that's going to be the first thing I write down here for my step 3, is that we got our Z of 1.645. And again, how we're getting that, that's just upon that 90% confidence that shows up in the problem. Now I do have all of my numbers to plug into my formula we see there. Alright, so our P hat is 0.29. Our Z is 1.645. And then our N is 600. And then again, the same thing on the other side, except for that plus sign between them. And then it's just a matter of us doing the math and making sure we get the order of operations correct. So the first thing I'm going to do is my power. So I'm going to do this square root piece that I have here. I'm going to leave everything else the same. And it's good to carry lots of decimals until the very end. So our standard error, that square root piece, is 0.018525. Notice it's the same number over here on the other side. There's no sense in doing the calculation twice because it's the same thing. Then we're going to do our multiplication. So our 1.645 times that 0.018 number gives us 0.0305. And then finally, doing our subtraction and addition. So that's what our math would look like. Connecting some terms now. So this 0.018525 number, that was the term we called in the last video our standard error, versus this 0.0305 is what we refer to as the margin of error. So step 3 is all the math side of it. Now the last thing I'm actually going to do before I do the interpretation is most people don't like proportions as decimals. They prefer them to be percentages. So if I make these percentages by just multiplying by 100%, we're going to get 25.95% to 32.05%. Now it might feel a bit better to do the interpretation. So how we're going to start our interpretation with is how confident we are. So I am going to say that I am 90% confident. This is very similar to us stating our alpha level when we do a hypothesis test. So I am 90% confident that, and now I'm going to do my numbers. So between 25.95% and 32.05% of, and now this is when step 1 is helpful, of Boone County elementary students are eligible for free or reduced lunch. So there's all 4 steps of a confidence interval worked out for our first problem. Now, a follow-up question that we may be asked is provided here. Do you think that we could say that more than 25% of Boone County elementary school students are eligible for free or reduced lunch? Why or why not? Well, first, let's make sure we're looking in the correct spot to determine this. I don't want to just look at p-hat. All right, so I mean, p-hat was 29%, but that was only from 600 students. And I'm trying to make a decision here again about all of the Boone County students. So I don't really want to just look at p-hat to determine that. What I can look at now is actually my interval. All right, let's look at that interval. We believe it's 25.95% to 32.05%. Is that interval entirely more than 25%? Well, yes, it is. So then here my answer would be yes. My entire interval is above 25%. So when would I not say that's true? If any of my interval is below 25%, my answer would have to be no. Even if this was 24.95%, right? That's really, really close to that 25%. But if any of that interval goes below it, I can't say it, because I don't trust one number in this interval any more than any other. So all of these numbers are just as likely in my mind to be P as any other. So there's our first example completely worked. In the next video, we're going to finally talk about why do I not always do a really large percent confident.